Hi, welcome back. So in this video, we are going to discuss June 2021 Pure Math 1 Quadratics. F of x is given as ax cubed plus 6a plus 8x square minus a square x, where a is a positive constant. So that means when we find out the answer or the value for a, it should be a positive answer. And also given that f of minus 1 is equals to 32. So f of x is given here as ax cube plus 6a plus 8x square minus a square x. Now, f of minus 1 is what we need to find out. F of minus 1 means wherever we have x on the right hand side, we'll replace it with minus 1. So a into minus 1 the whole cube plus 6a plus 8 into minus 1 the whole square minus a square into minus 1. So here this will become minus 1 the whole cube is minus 1 itself. So a into minus 1 is minus a. Minus 1 the whole square is positive 1. So 6a plus 8 into 1 is 6a plus 8 itself. Minus a square into minus 1. Minus a square into minus 1, we know that it is plus a square. And then it is given that it is equal to 32. It is equal to 32. So we can write 32 here. Now, bring this 32 to the other side. Let's collect the like terms. A square, 6a minus a is 5a. And 8 minus 32, because positive 32 goes to the other side, it becomes minus 32. So 8 minus 32 is minus 24 is equal to 0. Two numbers that when we multiply, we should get minus 24, and when we add them, we should get 5. So what are the two numbers that when we multiply, we'll get minus 24 and add to get 5? That is minus 3 and 8. Minus 3 into 8 is minus 24, and minus 3 plus 8 is plus 5. So this will give you a minus 3 into a plus 8 is equal to 0. Equate them separately, we will get a is equals to 3 and a is equals to minus 8. But it's given that here a is a positive constant. So a is equals to minus 8 we can ignore, and a is equals to 3 we can consider. So that the only possible value for a is 3. We already proved that the only possible value for a is 3. Using a is equals to 3, solve the equation and find f of x is equals to 0. Now what we need to do is, in this equation, wherever we have a, the f of x, wherever we have a, we will replace it with 3. So my f of x was ax cube plus 6a plus 8x square minus a square x. So a, replacing it with 3, so this will become 3x cube plus 6 into 3 is 18. 18 plus 8 is 26. 26x square minus 3 square. A is 3. 3 square is 9. 9x is equal to 0. F of x is equal to 0 is what we need to find out. I can see that there is x common in this. So I'll take x common outside. We'll be having 3x square plus 26x minus 9. Now we have a quadratic equation here, 3x square plus 26x minus 9. Two numbers to multiply to give you minus 27 and add to give you 26. That is minus 1 and 27. Minus 1 into 27 will give you minus 27, and minus 1 and 26, when you add them, will give you positive 26. So that satisfies the condition. So this becomes 0 is equals to x into, splitting the middle term. Instead of 26x, we will write 3x square plus 27x minus 1x minus 9. Now split them into two brackets here. 0 is equals to x into 3x square and 27x. We know 3x is common. We are left with x plus 9. And nothing is common, so I'll take 1 outside. Minus into minus is plus. Therefore, x plus 9. We always have to get the things inside the bracket the same. So we have 0 is equals to x into x plus 9 into 3x minus 1. We will get x as 0, x as minus 9, and x as 1 over 3. So now we have the x values here. We solved the second subdivision as well. Now find all the real solutions of 3y plus 26y to the power of 2 by 3 minus 9y to the power of 1 by 3. So now to get this value, we just have to first find out what the original equation was. So here, the original equation in this question was, let me clear this first. Okay, so the original equation here was 3x cube plus 26x square minus 9x. To find out the value for b first subdivision, we know the original equation was 3x cube plus 26x square minus 9x is equals to 0. Now the question that we have to find out is 3y plus 26y to the power of 2 by 3, y to the power of 2 by 3 minus 9y to the power of 1 by 3 is equals to 0. What we need to do is we need to compare both the equations. We need to compare both the equations and see instead of x, what we are replacing here with. So instead of x, we are replacing it with y to the power of 1 by 3. So instead of x, we are replacing it with y to the power of 1 by 3. We already have the answers for x here. X is equals to 0, x is equals to minus 9, and x is equals to 1 by 3. Now, instead of x, we'll replace it with y to the power of 1 by 3. Y to the power of 1 by 3 is equals to 0. Y to the power of 1 by 3 is equals to minus 9. And y to the power of 1 by 3 is equals to 1 by 3. Now, this is cube root. Cube root of y to the power of 1 by 3 is basically cube root of y. So cube root of y is equals to 0. And then cube root of y is equals to minus 9. And cube root of y is equals to 1 by 3. Now, cube root can never give you a negative answer, because if cube root should give you a negative answer, that means inside this root, it should be a negative answer. Inside the root, it can never be negative. If it's becoming negative value inside the root, we have studied that we don't have any real roots. So in this case, we can ignore this. Now, cube root of y, to remove cube root, we need to cube both the sides. We need to cube both the sides. So cube root and cube gets cancelled. We will get y is equals to 0. And then again, the same thing, cube root of y. To remove the cube root, we need to cube both the sides. So cube root and cube gets cancelled. We will be having y is equals to 1 over 3 cube. 1 cube is cube, 3 cube is 27. Y is equals to 1 over 27 and y is equals to 0 will be our final answer. And then for the second subdivision, we have to do the exact same thing here. So for the second subdivision, let me erase this first. We have to write down the original equation. The original equation was 3x cube plus 26x square minus 9x is equals to 0. The equation that we have to find out here is 3 into 9 to the power of 3z plus 26 into 9 to the power of 2z minus 9 into 9 to the power of z is equal to 0. Same like the previous first subdivision, we just have to compare both the equations and see what x represents here. Instead of x, we have 9 to the power of z here. We know already the x values. X is actually, when we simplified, we got x is equal to 0, x is equals to -9, and x is equals to 1/3. Now, 9 to the power of z, we need to replace x with 9 to the power of z. 9 to the power of z is equals to 0. 9 to the power of z is equals to -9. And 9 to the power of z is equals to 1/3. Now, what you need to understand is this: 9 to the power of z is an exponential function. 9 to the power of z is an exponential function. And if you check the graph of an exponential function, it looks somewhat like this. It approaches to 0 when the power is negative. When the power is negative on the negative side of the x-axis, when the power is negative x values, it approaches 0, but it will never reach 0. It will never reach 0. The value will never be 0. So an exponential function can never have the value as 0. And an exponential function can never have the value as a negative, because the graph is not going towards the negative y-axis. The graph is only on the positive side. So an exponential function can only have positive values. It should be greater than 0. It cannot be 0 also. It should be greater than 0. So exponential function cannot have a value greater than 0. So it can have only value greater than 0. It cannot have a value 0 here. It cannot have a value negative as well. So the only option is 9 to the power of z is equals to 1/3, can be written as 3 to the power of -1. 9 to the power of z can be written as 3 to the power of 2z is equals to 3 to the power of -1. Now, if the bases are the same, we can just equate the powers. 2z is equals to -1. Therefore, z is equals to -1/2. That will be the final answer for B, second subdivision. So this was June 2021 question. If you have any doubt, feel free to write it in the comment box. Thank you for watching.